All right, good morning, guys. Today we're going to focus on proportional reasoning in tables and equations. We're going to focus a lot on how the table changes and whether or not it's proportional. This week on your agenda, to keep you kind of at pace, you have two lessons: proportional relationships in tables and graphs, which is what I'm going to focus on today, and then using proportions to solve problems. They both heavily relate to last week. That's why I did the checklist for 2 weeks, because they all kind of blend together really well. Just a heads up, we only have 2 weeks left, and the last week is only 2 days because all the lessons are due on the 30th. So just kind of take a moment to see where you are in the program and make sure you're about halfway, which should be 8 completed lessons. Some vocabulary that I believe we went over last week, and we're just reiterating this week, is rate of change. A rate of change which describes how one quantity changes in relation to another quantity. The constant of proportionality is the ratio between two directly proportional quantities. So that's like when we had y equals 2x. The 2 was the constant of proportionality. Proportional relationships is a relationship in which two quantities vary directly with each other. The graph of the proportional relationship is a straight line through the origin. The through the origin is very important. And if you'll remember, the origin is at 0, 0 on the graph. All right. So what do you notice? You can unmute and tell me something that you notice about either of these two tables. There's no wrong answers. Okay, I'll start. Over here, I notice that the numbers are similar, but the decimals are in different places. Does anybody notice anything about this side? Good. They multiplied 2 times this number to get this number, and then they multiplied 2 times this number to get this number. Is there something else you notice about this table that makes you uncomfortable? I'll tell you that this one being weighed in ounces and this one being weighed in pounds makes me very uncomfortable, because I know that math works better when you're in the same unit. And so I don't think this one is going to work out to be proportional, even though I can multiply 2 times this to get this and 2 times this to get this, because of those differences in my units. This one, I can tell that if I multiply this number times 10, it'll give me this number. And if I multiply this number times 10, it'll give me this number. So I think that this one would end up being proportional. Okay, let's go on. All right, so looking at these two tables, we're going to determine which one is proportional and which one is not. In order to be proportional, your ratio must be equivalent to y over x. And all of your ratios would have to match in order to be proportional. So I'm going to take this and I'm going to put, sorry, my handwriting is going to be really bad on the screen. I'm going to put y, which is 75, over x, which is 1, and that's going to give me 75. I'm going to do that again on the next table. 120 divided by 2. Is that going to give me 75? Nope, it's going to give me 60. 165 divided by 3. That's going to give me 55. Is this looking like it's going to be proportional? Are these all going to be equivalent? Definitely not. So let's move over to this one. All right, so we have 45 over 1. That equals 45. We have 90 divided by 2. That still equals 45. Oh, we're on the right track. 135 divided by 3 is equal to 45. So on, which I noticed that This times 2 gives me this. So this times 2 gives me this, which means it is also equal to 45. And then if I multiply this times 5, it gives me this, and this times 5 gives me this. So this one is also equal to 45. Sometimes if you don't like long division, you can find something in the table that will help you get to the other one. For instance, I know that this plus this equals 5. So this plus this should equal this, which it does. So here is our proportional table. And we know that it's proportional because all of our ratios turned out to be 45. All right, so using the rate of change to solve problems. So if they give me this snippet of a table, can I use it to find basically what goes in here, which we can call X if it makes you feel better? Sure we can. I'm going to set up a proportion. You can continue this proportion box if you want to and just make more table parts. Okay, so I personally can't figure out what I would multiply 2.5 by to get 10. I'm not that great at my multiplication facts, but I do know that I can go down to 1 pound very easily by dividing by 10. So if I divide this by 10, can I divide this by 10? Yeah, 10 is one of the easiest ones to divide by because you know that it just relocates your decimal. So then this would be 1.824. Okay, now do I know what 1 could multiply by to get 2.5? Sure I do. I know I can multiply by 2.5 to get 2.5 right here. Can I multiply this by 2.5 to get my X value? Sure I can. Remember when you are multiplying that you don't need to line up your decimals. You do, however, need to apply the decimals at the end. Okay, 20, 10, 40 plus 1 is 50, and 10. Did I do that right? It doesn't match what I had on my paper yesterday. 25 times 2 is 10, 11. Oh, nope, right there. That one should have been a 2. Sorry about that. And 541. Ooh, let me. This is why I did this early, so that I would have a paper to look off of, because sometimes I make rushing mistakes. 20. 5 times 2 is 10, 11, 12, carry 1, 41. That's what I did. I got a little crazy. 9. There we go. And then I'm going to solve it again with the 2. So 2 times 4 is 8, 2 times 2 is 4, 2 times 8 is 16, carry the 1, 2 times 1 is 2, plus 1 is 3. All right, now we're going to combine those, and that's going to give us 6, 5, carry your 1, and then now we need to look at our decimals. If we had 3 decimal places in this number and 1 in this number, then our final answer should have 4 decimal places. So our final answer is going to be 4 56/100. And then I would look and see if that makes sense. Would it make sense for it to be $4.56 for 2.5 pounds if it's $18 for 10? Yeah, that definitely makes sense. Or if it's almost 2 for 1 pound, then yes, it definitely makes sense. All right, sorry about that multiplying brain fart. I do teach 8th grade math regularly, and we use a lot of calculators, so it's been a while since I've done real multiplication. All right, I got 2 more examples for you. Hang in there with me. In a graph, it's really easy to see the proportional relationship, and I know we talked about this last week. You're looking for where it crosses the y-axis. So in this case, it crosses it here, here, and then here. And then as we talked about in the vocabulary slide, it talked about going through the origin. And the only one that goes through the origin is this one. And you're also looking for this equation, the y equals kx. That is the equation for proportionality. It has no plus or minus anything. It has to have both variables. And you can't have this plus at the end. All right, and our last example comes straight from Imagine Math, so you may want to get a pencil, or you can just watch this video again if you get confused or lost. We have the number of dollars and the number of pounds, and you want to figure out which one goes in which example here. So, in order to put this one into an example, I'm going to need to get one of the variables by itself. And if I'm looking for 1 pound, then I need to get this 2 off of here. Well, if I'm trying to divide by 2, it's the same thing as multiplying by a fraction. So this would be 1/4 dollars per pound. Okay, and then here, I'm just comparing from these two right here. So, how many dollars is it per pound? It's $2 for 1 pound. This one, they were very friendly. So this one is actually $2 per pound. Okay. This one, it's $1 for 2 pounds. So how much is it for 1 pound? It is divide by 2. Divide by 2. If it's $1 for 2 pounds, it is half a dollar for 1 pound. So, this I believe is a typo, and it should have been 1/4 of a dollar per pound, which is 25 cents a pound. But I believe they put a typo here. And then this one would be neither, because it's 50 cents a pound, or $1/2 per pound.